Hello, this is Professor Kuehn, and welcome back to my lectures on astronomy. You've probably heard of the Hubble Space Telescope, and if you haven't, well, perhaps you've seen some of the wonderful photographs that it has taken over the past probably 20 years while it's in orbit around the Earth. The Hubble Space Telescope was named after Edwin Hubble, and today what I want to do is begin talking about the work of Edwin Hubble. This is in Chapter 26 in a Student's Guide Through the Great Physics Text, Volume 1. The chapter is titled The Structure of the Universe. Since there's a lot in this chapter, what I think I will do is begin sort of reading through this together for you and making comments here and there as we go. So let's start with the introduction. Edwin Hubble was born in 1889 in Marshfield, Missouri. He received his Bachelor of Science degree from the University of Chicago in 1910, where he concentrated on astronomy, mathematics, and philosophy. As a Rhodes Scholar at the Queen's College in Oxford, he studied jurisprudence, that's the study of law, jurisprudence, literature, and Spanish. He returned to his interest in astronomy after serving as a high school teacher for a few years, earning his doctorate from the University of Chicago in 1917. There, he carried out photographic studies of faint nebula at the Yerkes Observatory in Williams Bay, Wisconsin, home of the largest refracting telescope in the world. And here I show an image of the telescope in Williams Bay. By the way, the Yerkes Observatory, you can still go to it. It was built by the astrophysics and astronomy departments of the University of Chicago in, I think it was 1897, and for many years it was the largest, it still is the largest refracting telescope in the world. And I think it was just bought in 2020 of this year by the Yerkes Future Foundation, which is trying to keep it running and open to the public if possible. In any case, after serving in the United States Army in World War I, Hubble went to work at the Mount Wilson Observatory, where he studied Cepheid variables in spiral nebula. You might remember Cepheid variables from when we studied the work of Henrietta Leavitt, whose groundbreaking work on Cepheid variables led to the development of a way to measure the distances to distant galaxies. He was building on the work of Henrietta Leavitt, Einar Hertzsprung, Vesto Slipher, and Harlow Shapley, and he was able to establish a relationship between the recessional velocities of galaxies and their distances from the Earth. This is known now as Hubble's law. The Hubble Space Telescope, which I mentioned a moment ago, named after the famous cosmologist, was launched into low Earth orbit in 1990 and has subsequently produced thousands of popular and beautiful images of galaxies and other astronomical objects. In the following reading selection, which appeared in the Scientific Monthly in 1934, Hubble begins by describing how nebulae appear when viewed through powerful telescopes, and also how their distribution throughout the observable regions of the universe is calculated. After this, he proceeds to explain his famous velocity-distance relationship. As you study this text, try to identify any assumptions that are made by Hubble. Are his reasonable assumptions? And is there a better approach? Okay, let's start into the text. This is on page 322 in a student's guide. This is called The Exploration of Space. Hubble begins, I propose to discuss some of the recent explorations in the realm of the nebulae which bear directly on the structure of the universe. The Earth we inhabit is a member of the solar system. The Sun with its family of planets seems isolated in space, but the Sun is merely a star, one of the millions which populate our particular region of the universe. The stars are scattered about at enormous intervals, but on a still greater scale, they are found to form a definite system, again isolated in space. On the grand scale, we may picture the stellar system drifting through the universe as a swarm of bees drifting through the air. So you might remember that Immanuel Kant in the 1800s came up with the idea of island universes. And this is how he termed these galaxies, what we now call galaxies or clusters of stars. Kant called them island universes. So here you have Hubble that is reiterating this perspective that stars are clustered together in galaxies that are widely separated in the universe. He goes on to say, from our position somewhere within the system, we look out through the swarm of stars, past the borders into the universe beyond. It is empty, for the most part, vast stretches of empty space. But here and there, at immense intervals, we find other stellar systems comparable with our own. They are so distant that in general we do not see the individual stars. They appear as faint patches of light, and hence are called nebulae, that is, clouds. The nebulae are great beacons scattered throughout the depths of space. We see a few that appear large and bright. These are the nearer nebula. When we find them smaller and fainter then we find them smaller and fainter in constantly increasing numbers, and we know we are reaching out into space, farther and ever farther until, with the faintest nebulae that can be detected, with the greatest telescope, we have reached the frontiers of the known universe. This last horizon defines the observable region, the region of space which can be explored with existing telescopes. It is a vast sphere, some 600 million light-years in diameter, throughout which are scattered 100 million nebulae. And here we have, in figure 26.2, an image of the Whirlpool Nebula M51 in Canes Venatic. This is the first nebula in which a spiral structure was discerned. It's about 1 million light-years from the Earth, and it was taken at Mount Wilson Observatory at the Carnegie Institution. By the way, we came across a different distance unit when we were studying the work of Henrietta Leavitt, the parsec. Remember, the parsec was the distance to a star such that it exhibits 1 second of parallax during the time that the Earth goes around the Sun. There are about 3.26 light years in a parsec, if I remember correctly. Hubble goes on to say the question immediately arises as to whether the nebulae form an isolated supersystem analogous to the system of the stars, but on a still grander scale. Actually, we find the nebulae scattered singly, in groups, and occasionally in great clusters. But when very large volumes of space are considered, the tendency to cluster averages out, and to the very limits of our telescopes, the distribution is approximately uniform. If the observable region is divided into 100, 1,000, or even 10,000 equal parts, the nebular contents of the various fractions are very closely similar. There is no evidence of a thinning out, no trace of a physical boundary. The realm of the nebulae, we must conclude, stretches on and on, far beyond the frontiers. So what is Hubble saying here? He's saying that certainly there are regions in space, there are stars, and other regions in space where there are no stars. So the universe is certainly not completely uniform or completely homogeneous. And yet, if you look up into the sky, there are clusters of these stars forming nebulae. And then if you kind of break the sky into 100 even parts, there are about the same number of nebulae in each of those 100 regions you look at. Or if instead you were to break the sky into 1,000 equal parts, there would be the same number, a smaller number, but the same number of nebulae within those 1,000 parts, and likewise 10,000 equal parts. So the conclusion that he comes to is that the universe is roughly homogeneous. There's roughly an equal distribution of nebulae in each of the observed regions of the sky. Observations, he says, give not the slightest hint of a supersystem of nebulae. Hence, for purposes of speculation, we may invoke the principle of uniformity of nature, and suppose that any other equal portion of the universe chosen at random will exhibit much the same general characteristics as a region we can explore with our telescopes. As a working hypothesis, serviceable until it leads to contradictions, we may venture the assumption that the realm of the nebula is the universe, that the observable region is a fair sample, and that the nature of the universe may be inferred from the observed characteristics of the sample. So here Hubble is laying out what he believes to be a reasonable assumption. That is, if we look at many different regions of the universe that we see, and the nebulae are scattered uniformly throughout that region, then it's a fair assumption to say that every region, even the ones we cannot see, have a uniform distribution of nebulae. This is an assumption, he points out here, and yet he thinks it's a fair assumption. What do you think? We'll stop there and go on next time with characteristics of the observable region.